Hi all, today I am going to discuss a comparative study between electric field intensity due to a electric dipole at any point on its axial line. This is an electric dipole. I have to find out electric field at point M, which is present on the axial line or on the axis of this dipole. Similarly, I have to find the magnetic field intensity due to a bar magnet, which we can find a magnetic dipole, which you can use as a magnetic dipole. So magnetic field intensity due to bar magnet or due to this magnetic dipole at any point on its end-on position. Axial line and end-on position are same thing. When a line is passing through the axis of a magnet and at any point you are finding magnetic field intensity, that is called axial line. So before going to discuss, first I have to understand what is the expression for electric field intensity due to Q charge at any point A. Suppose at O I am taking a positive charge Q. Let us consider a point A which is at a distance R apart from Q. Now electric field due to Q charge at any point A will be given as 1 by 4 pi epsilon 0 Q by R square. This is the expression for electric field intensity due to a point charge at any point. Similarly, magnetic field intensity at any point due to a north pole or south pole can be given as mu 0 by 4 pi. This is same as your electric field. In electric field 1 by 4 pi epsilon 0 is used. In magnetic field mu 0 by 4 pi is used. Both of them are constant. Epsilon 0 is called permittivity of free space, whereas mu 0 is called permeability of free space. And for electric charge, I have to take an analogy that is called pole strength QM. In my previous video, I have already discussed what is a pole strength. So pole strength divided by same distance will be there because both of them are inverse square law. Electric force or magnetic force are inversely proportional to square of the distance. Okay, so this is the expression for magnetic field, and I am going to use these things in finding electric field intensity due to a dipole. Means now I am considering two charges at a time. Simultaneously I have to find out electric field intensity for two different charges at one point, that is on the axis of the dipole. If AB, let us consider AB is a dipole whose length is 12. I have taken length of the dipole as 12. So 12 is length of the dipole. Here, I can say AB equal to 12. Now, let us consider a point M on the axis, which is R distance apart from the midpoint of the dipole. So here O is midpoint of the dipole AB. Just understand this. This one will be very easy comparing with this. So 12 is the length of the dipole AB. O is the midpoint of the dipole. So I can write AO equal to BO equal to length L. So this much will be L. Now let us consider a point M on the axis of the dipole, which is at a distance R apart from the midpoint. From the diagram, OM is R. So R is the distance between the points O and M, where O is the midpoint of the dipole and M is the point at which here I have to find out electric field intensity due to both the charges. Okay, so basically I am going to use vector technique here. So now I am erasing it out. I am just writing for your convenience so that you will be comfortable. Now, what is the distance from B to M? Look, from O to M is R. From O to B is L. From O to B is L. O to M is R. O to B is L. Now, how much distance is this? This will be R minus L. So, I am writing distance between B and M is R minus L. OM is R. OB is L. So, this will be R minus L. Similarly, What is the distance from minus Q to M? Look, AM. So AM is how much? AB plus BM, or else you can write AO plus OM. OM is your R. AO is your L. So it will become R plus L. Just check it clearly. AO plus OM. AM equal to AO plus OM. But AO is L plus OM is R. That's why it is L plus R. So now you're thorough. Why I am finding distance? Because I am going to use this formula. Electric field intensity due to a point charge at any point is given as 1 by 4 pi epsilon 0 Q by R square. I am going to use this formula. That's why I have to find the distance of this point M from both the charges. So distance of point M from plus Q charge is R minus L, and distance of point M from minus Q charge is R plus L. So to make you more clear, I am erasing it out. But you do not need to erase it out while solving or deriving this for CHSE or CBSE exam. To make you look better or easy, I am just erasing it out and writing only necessary things. What are the necessary things I am going to write here? The distance from plus Q charge to M is R minus L. Already I have discussed. The distance from minus Q to M is R plus L. Already I have discussed. Now another thing. Electric dipole moment vector is always from minus Q to P, minus Q to plus Q. That is P vector. And along the same direction I can also take P cap. P cap is unit vector of electric dipole moment vector, which is always from minus Q charge to plus Q charge. Everything I am going to use here. Just you need to understand it better. Now, electric field intensity due to plus Q charge at point M. Electric field intensity due to plus Q charge at point M will be given as 1 by 4 pi epsilon 0. Here write Q, and distance from B to M is R minus L. R minus L square. So this is the distance of plus Q charge from M. That's why EQ. I am just using this formula. So this is a scalar way of writing. Now I want to write it in a vector form. Then things will be easier. So already I have mentioned in my previous video, direction of electric field intensity is always away from positive charge. So I am assigning the direction. This will represent electric field intensity due to plus Q charge, which is always away from plus Q charge. If this is plus Q charge, electric field intensity is always away from plus Q charge. So I am putting a vector sign here. One can assign from origin to right side, x-axis, positive x-axis, I cap. Or else, just look at the diagram. Direction of E plus Q vector and P vector are same. But I cannot write P vector here because P vector contains some magnitude. That magnitude is nothing but charge of the dipole into length between the two dipoles. So here, basically, dipole moment P is Q into 2L because charge is the Q is the charge of the dipole and 2L is the distance of separation between the two charges. I have taken 2L. So what I can write? E plus Q vector is directed along the same direction with P cap. So I am just putting a P cap because it will not change its magnitude. Magnitude of P cap is 1. Magnitude of P cap is 1. So it will not change its magnitude. So E plus Q equal to 1 by 4 pi epsilon 0 Q P cap R minus L square. And one trick, whenever you are writing expression for force or field due to charge, don't use negative sign. Just use vector sign. It will be easier for you. But whenever you are writing potential, you have to use negative sign. I'll discuss in my potential class. Now I am writing electric field due to minus Q charge at M. So electric field due to minus Q charge at M, the distance from minus Q to M is R plus L. So I can write R plus L square. Now don't use minus Q, just write Q. And this will be 1 by 4 pi epsilon 0. But use vector sign. So already I have mentioned in my previous videos, direction of electric field intensity is always towards negative charge. Direction of electric field intensity is Here minus q charge, I want to find out electric field intensity here at M. Its direction is from M towards left side. So minus q. If I put a vector sign here, it is exactly opposite to the direction of P cap. That's why I am taking minus P cap. Now things is very easy. Now what we can do? You have to find E axial, because I want to find out net electric field intensity due to both the charges plus q and minus q. That's why I have to add them. Now things are very easy. If you observe these two equations, you will find q p cap by 4 pi epsilon 0. Q p cap by 4 pi epsilon 0 are common. Now here I will take 1 by r minus l square minus 1 by r plus l square. So this is the expression. Now I have to solve it. Now if you solve it, you will get here r minus l square, r plus l square. So this will be r plus l square. I have taken LCM, and this will be minus r minus l square. So now things will be coming like this. Q p cap by 4 pi epsilon 0. Now this will, I can write r minus l into r plus l whole square. Now I am breaking it, r square plus l square plus 2rl minus within bracket r square plus l square minus 2rl. I am using extra bracket in not to make any mistakes. I am not going to derive this. I'll just write the expression. Your job is to derive it and send the doubt in my WhatsApp number. But please look at it. The way I am deriving it, it is same as that. I'm just going to write the expression. So, but I'm talking physics behind this. I'll be talking about what are the physics behind this and how to derive it. So q p cap by 4 pi epsilon 0 r square l square. Now I'm going to solve it. This will be a minus b, a plus b, a square minus b square, r square minus l square whole square. Now this will be r square plus l square plus 2rl minus r square minus l square minus minus plus 2rl. So everything will be caught. Now 2rl, 4rl. So here I am writing, then after some time I will erase it out. So my E axial, it is really important to understand how I am using this. Some students always ask, so what are the chapters from 11th standard we should learn to understand electrostatic? Only 2 chapters, vector and gravitation. Look, I am using vector here, and also some technique of gravitation. So E axial. So here I got E axial equal to q p cap by 4 pi epsilon 0. Writing here q p cap by 4 pi epsilon 0. Now what are the things I am getting here? 2rl plus 2rl. This will be 4rl. So I am writing here 4rl divided by r square minus l square. I think all of you are clear. Now I am quickly erasing these things so that I'll get space. It's very easy to teach offline, but it's very difficult to teach online because you have to manage the space. Okay. So what I'll do, I'll write q into 2l. Why I'm writing, I'll say into p cap into 2r divided by 4 pi epsilon 0 r square minus l square square. So what I did here, I take q and multiply with 2l. Q into 2l into p cap into 2r. Now already I mentioned q into 2l is your dipole moment p. So I can take q into 2l is p into p cap into 2r divided by 4 pi epsilon 0 r square minus l square square. So this will be E axial. So now p into p cap, you already know in your 11th standard, a into a cap is vector a. So this will be 2 into p vector. I am taking this 2 into p vector into r by 4 pi epsilon 0 r square minus l square square. This will be the expression for electric field intensity due to a dipole at any point on its axial line. But if I take special case, what is a special case? Let us consider this length of the dipole. This 2L is very, very smaller than R. Now 2L is very, 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 very less than R. So neglecting L square in the equation. Neglecting L square in the above equation. Let's say equation 1. Neglecting L square in the above equation 1. So this will be the axial 2p vector by r 4 pi epsilon 0 r 4 r 4 pi epsilon 0 r to the power 4 r square I have neglected L square. So my net expression will be coming E axial equal to 2p vector. Now this r will be cut here, it will be r cube. So 2p vector by 4 pi epsilon 0 r cube. This is the expression for electric field intensity due to a dipole at any point on its axial line here. So if I am trying to say you the direction, this is A, B, this is the point P where I want to find out electric field intensity. Already I have mentioned the magnitude. So magnitude of electric field intensity is given in this equation 2. So the direction of electric field intensity at P, here I have taken minus Q charge, here I have taken plus Q charge, is along this direction, E axial, because this is also the direction of P cap or direction of P vector. So basically electric field intensity due to a dipole at any point on its axial line is directed along the same axis or along the direction of electric dipole moment vector. So I think you must be clear with this. So without doing much derivation, directly I am writing everything are same, all the diagrams are same. Let us consider a bar magnet having south pole, north pole, because why I am taking south pole here? Here I have taken at A minus Q charge, so I am taking south pole at A. So let's say pole strength of south pole is Qm, pole strength of north pole is Qm. So let us consider O is the midpoint of this bar magnet whose length is 2L. Let us consider a point P on the axis of the bar magnet, which is called end-on position. We want to find out magnetic field intensity at P due to both the poles. But for one pole, magnetic field intensity is given as P equal to mu 0 by 4 pi Qm by r square. So what I want to do is, I will write magnetic field intensity due to south pole first. Okay, here I have written due to plus Q charge, so here also I am just matching it. Magnetic field intensity due to north pole first. Here plus charge, so I am taking north. So what is the distance from north pole to point P? This is same as here, that will be r minus L. So I can write mu 0 by 4 pi Qm by r minus L whole square. Just I am matching this formula here. Qm is the pole strength. Okay. Now direction of magnetic field is always away from north pole. So this is the direction of magnetic field, and also direction of magnetic dipole moment is from south pole to north pole. Just like your electric dipole moment. P vector is from negative charge to positive charge. M vector, magnetic dipole moment vector, is from south pole to north pole. So here both are along same direction. I am writing n cap. Now Bn. Similarly, for Bs I am writing mu 0 by 4 pi Qm. Now tell me what is the distance from south pole to P. From south pole to P will be r plus L. I am just erasing it out. From south pole to P will be r plus L. Already I have discussed here. So r plus L square. Now direction of magnetic field due to south pole is always towards the south pole, which is opposite to the direction of magnetic dipole moment. So I am taking m cap minus m cap here. This is the m cap. So now magnetic field intensity due to bar magnet at any point on its end on position will be, without doing much, I can follow this formula. 2 will be 4 pi epsilon 0 is there, so mu 0 by 4 pi will be definitely there. Now here r cube, so definitely here will be r cube. Now here p vector, now here definitely there will be m vector, because p vector is electric dipole moment vector, m vector is magnetic dipole moment vector. So another quantity 2, so here it will be 2. So this is the desired expression for magnetic field intensity due to a bar magnet at any point on its end on position, or you can say at any point at a distance, at some distance apart from the midpoint of the magnetic dipole. So hope you are clear. I know this is a complicated class, so stay tuned just a minute, and once again erasing all the expression, just showing the technique or the direction how actually I am finding and what are the important things required to derive these two formula. First important thing, electric field intensity due to a point charge expression. This is really important. Similarly here, magnetic field intensity due to any pole, maybe north pole or maybe south pole, mu 0 by 4 pi. Okay, you can take north pole, mu 0 by 4 pi, qm by r square, or simply magnetic field intensity due to any pole. These are the things we require. Similarly, important things, electric field, direction of electric field is always away from positive charge. Direction of magnetic field is always away from north pole. Similarly, next point, direction of electric field is always towards the negative charge. Similarly, direction of magnetic field is always towards the south pole. These three things are important. Now next important thing, direction of dipole moment is from minus q to plus q, that is p vector or p cap. Direction of magnetic dipole moment is from south pole to north pole. This is magnetic dipole moment vector, or else m cap. Here in this situation I have taken magnetic dipole moment as charge into length between two charges. For easy calculation I have taken the length of the dipole as 12. Similarly, formula for magnetic dipole moment will be pole strength into length between two poles of a bar magnet. Now the final answer will be, if this is the electric dipole, now if this is the point N, now electric field intensity, net electric field intensity due to dipole is like this, EXL, and this is the direction of dipole moment vector. I mean EXL and P vector are parallel, they are along same direction. Similarly for bar magnet, I can write this will be B and on position at point P I am finding. So this is the direction of B and on, and this is the direction of magnetic dipole moment. So magnetic field intensity due to a bar magnet at any point is also along the same direction or parallel to the direction of magnetic dipole moment. Hope you are clear. Thank you.